Okay, and so for this one, we're really going to do just some small activities for the water cycle, right?
Yep.
And these are things that you could do in groups, easily do in groups. Some of this are things that you could do a walkthrough on for remote instruction too.
Yes.
And so this is, if your kids don't have a thermometer, a lot of classes will start with the thermometer one.
Okay.
A lot of, I mean, if it's remote instruction, if it's in the classroom, it's really great. You can use different, just a same material. That way we control a variable there, right? And do a, where it shows one black and one white, because we're talking about where does the energy come from on the earth, right? Where does all energy come from on earth? And it comes from the sun. We get our energy from the sun. And so, and our weather patterns, things like this, are from indifferential heating and cooling of the Earth's surface. And to show that the Earth's surface, that we're absorbing energy, that's where we use the light and dark.
Okay.
And this, I mean, it comes from, it's like my early elementary days. You know, we did this in elementary to show that energy comes from the sun.
Yeah.
And so, I'm going to take a picture real fast of these thermometers. What I did, I grabbed 2 calibration thermometers, and that way you know I took the picture now. I grabbed 2 calibration thermometers. These are thermometers that we've already calibrated, and actually teachers calibrated them in a workshop, and so, and they both were calibrated right at 0, and so these, there's no adjustment.
Correct.
And so we will put a link in that Google slide for the how to calibrate them. The Globe program has a really good calibration what do you call it? Protocol. Thank you, protocol. And so we'll do that, then I'm on a short leash. Think this will be long enough?
Yeah.
Yes, I'm gonna move these up just so to make sure that I'm even. I don't want anyone to say I wouldn't not be even as Stephen can be. Best I got, sorry. But so now we're heating them up with the lamp, trying to be as uniform as possible. About the same difference from.
Did you take the temperature prior to heating it?
Yeah.
Oh, okay.
That's why I just took the
that's what you
photograph.
took. Oh, okay, got it.
I just took the photograph of the thermometers before.
Okay.
I guess before we put them in.
Yeah.
And so they were sitting on the desk right beside this, so all that had been the same temperature.
Yeah.
And so now that we're heat lamping them and warming up, the thermometers, I mean, this is what we used in the old school days, right? Is thermometers. Now, I know a lot of classrooms have the infrared thermometers.
Yes.
And you can get these at, I should put this on some kind of stand because I'm moving around. I'm trying to talk and I can't talk without both hands. And so I got it.
Okay.
I'll survive. But she's like, oh, he's serious. He probably can't. A lot of people have the infrared thermometers.
Yeah.
Now you can go to, I mean, heck, your local marts.
Yes.
Now I say that very generically.
Yes.
All your local marts, they have them. I mean, $20. You know, it's you can order them online places and stuff. Don't get a big fancy one. You don't need it. $20 ones were great. This was just a cheap one we picked up at a local mart a few years ago, and or it's one that we ordered offline. I don't remember, that they all got mixed up. But you don't need a super duper fancy one. These were great, and you can do a lot with them. I know, like the Globe program we mentioned, you can do temperature. They have investigations for atmosphere and ground temperature is one of them.
Surface temperature.
Yeah, surface temp. Thank you. Surface temperature is one of them, and a lot of kids will do investigations using the infrared thermometer on like the asphalt in the parking lot versus the grass. Which one is warmer? Even trees, shade versus something that's not shaded for a while. And those are, if you're looking for investigations for students to do, those are awesome investigations. And we encourage you to get your students doing investigations and doing figuring out how to do protocols for things. The surface temperature is an easy one, especially if you have an infrared. Look at globe.gov, look that up. That's a great one to get kids started about scientific thinking. And all those are protocols done by scientists and educators together. They've all been tested out. And so it's a NASA-sponsored program. Then it's supported also NOAA and Department of State, U.S. Department of State. And so that's a really good program. It's in, I don't know, over 120 countries, but I don't remember how many now. So what's our infrared telling us on these two now?
black cloth, right now we're getting a reading of 64.4 degrees Celsius.
Okay.
And the white cloth is 33.9 degrees Celsius.
Oh, so that's a huge difference already. All right, so just because we don't believe you, let me take a picture of that so I can show the world.
Oh, now it's raised.
All right, there we go. On that one, now to the next. All right, they saw me take the picture, so we'll put that there in it so you know for sure that we're not fooling you. And although why would we for this? You're not my students. I'm not going to lie to you. Well, you know.
Yeah.
So, all right. Now, if you have the alcohol-filled thermometers, let's check them out.
Okay.
Mine reads just a hair over 30 degrees Celsius. It looks like 30.5.
Okay. And mine is reading at looks like about 29.5 degrees Celsius.
Not as big of a difference. Not as big of a difference. And it's, of course, these are under there, and so these are going to take longer.
Yeah.
And so it's, if you want a bigger difference, you're going to have to wait longer on the alcohol-filled ones. And so if you want something quick, this will give you a really, really quick reading. So it kind of shows the difference between those. And as I've said in other videos for some of the different PDs, I have my elementary teachers teach water thermometer. You know, if it goes up, the temperature's going up. But I personally, I think with technology the way it is, we don't have to use analog devices anymore.
Yeah.
That's not real world. And I know some people hate me for saying that. I'm all right with that. You'll find better reasons to hate me eventually. Get to know me. Don't worry. But we live in a digital world.
Yeah.
There's really no need to run those, in my opinion. They're cheaper, and so that's nice. And I mean, these are actually we got out of our hydrology thing, which is why they're even slower to go. We should have maybe taken the covers off of those.
Yeah.
But we have those protective covers on because kids use those to check the water temperature.
Temperatures.
And so we like those covers on there, so because we like not having broken glass in the water. And so, but that's one just to show that we're getting energy from the sun. The sun is warming things up. Then we can start talking about those currents, the convection currents in the atmosphere, right? So we can discuss convection currents atmosphere. What happens when you have this land that's darker, this nice rich soil, and it's soaking up more where the water is reflecting, Oh, well, that's where we're getting our convection current started. And so, and then we can even talk about the island heat effect. We want to bring in people, anthropologic effects of our climate. When you talk about the island heat effect, where your cities with all the asphalt is warming up, and it's warmer there. And that impacts fronts as fronts come through. Because a front comes through, it's warmer over that city. So you have all that moisture, all that energy coming into those storms. When that energy comes into those storms, it builds it up stronger. And so actually the lee side? Wayside, lee side, I don't remember. That other side of the city for the storm. Oh, it's so embarrassing, I should know those things. But the other side of the storm is more intense. So if you live on the far side of a big city where most of the fronts come through, if you live on the other side, you're going to most likely have more intense storms there. And we're finding, that out through science. Simple science like this is teaching us that. Okay, we'll push that to the side. And our next thing is very simple. We're going to show this. And this is just a water cycle in a bag. And some of you might have done this. Have the students draw. You can give each, if they're doing it at home, they can use a baggie. Most kids have baggies at home. Most people do. Right. And so we're just putting some water in it. And so they're not even trashing it. They can reuse, they can pour the water out when they're done and reuse it for something else. So they're not even asking them to ruin their stuff. But they draw the clouds down here. I put a line down here for the water, and then we put our arrows to show evaporation, condensation, right? And so, and this is kind of like a mini system. Once we seal this, it's a mini system. And so I tend to put a couple drops of blue food coloring in it. And so we'll just put a little bit up to the line, put some blue food coloring in it, and then what's really nice is we can just tape these to the window.
Oh, cool.
Because as the sun shines in the window, it'll warm that up, and that liquid water will evaporate to turn into a water vapor, and then as it gets towards the top, it'll start condensating on the plastic at the top, and it'll run down. And you'll be able to see like a model of the water cycle right there in a baggie.
Nice.
And so if you're teaching remote, this is something you can assign your students without having to worry about. Most of them are going to have some sort of baggie. And it can be any kind of baggie, probably any size baggie. And we tend to use this size because it's a convenient thing, but probably any size. I've just did one of these because right before the video, and I actually taped it on our file cabinet, and I'm going to see how well the light does. We'll put the light, shine it on it, and see if maybe I'm going to time it and see if in like 40 minutes or so, see if we can get a difference. I'm not sure. I'll post that in the document, the pictures, after like 40 minutes, so we can see if we can do it maybe even in a class period with enough light. Now this is something we did in elementary, but we taped it up, then we'd look at it, you know, at the end of the school, you know. And so you might, if you tape it in the morning, you look at it in the school or the next day. It's not something we're doing quickly. And so I don't know if it's something you would have to like assign in the middle school more, or if we can just put it up and then kids throughout the day can document, picture and document. And so at that point you're collaborating. That's
Science
what science
journal,
works.
right? Science notebook.
And that science journal, yep, they can write. And then what I like, if you do that, I would encourage have your morning and afternoon classes both write their date on the board, their observations.
That'd be good.
On the board, and maybe take pictures of it and put it in the class folder. And so we could see, oh yes, there was more condensation in the afternoon when the sun was hitting it. And so there's that one. Now the last one we have here, I'll move my phone. It just seems like a smart thing to do.
It does.
All right, there's yours.
Okay.
And mine. Now this cup represents all of the water in the world.
Oh.
Okay. You have the whole world's water in your hands.
Wow.
The whole world in your hands. All right, so what you have to do is pour half in each cup, or each of these two cups, right? Oh man, I'm good. I'm calling it. Might need glasses. Oh wait, I got them on.
Well, that's
Pretty good?
Yeah.
All right, set A to the side. All right, so we have, what percentage of the world's water in this cup?
50.
50%.
50%.
All right, so let's divide it in half again. It's a nice math lesson. We're just doing math with water. Oh wow, that looks really good. Got it?
Got it.
All right, take your, pick C.
Okay. Do what now? This is why we double it.
Dump C into A.
Dump C
Your
into
students
A.
won't spill anything, will they? All right.
Okay.
This will work still. This will work. Don't panic. All right. Keep C.
Keep C.
Take B and divide it in half again.
Okay.
All right. Anybody know how much we got now? We have now?
I'm gonna say 12.5%.
All right, because we had, that's what we forgot to ask here. We had 25% here, right?
Yep.
All right, take C, dump it in A again.
Okay.
All right. So we have how much here?
I think 12.5%.
12 and a half. Let's divide it in half again.
Okay.
What is this? This should be about fork time, right?
Yeah.
All right.
Okay.
All right, take C, dump it in. All right, what do we have now?
6.25.
All right, let's see if we get one more divide. Let's do a fifth. Let's say that's pretty close. Good?
Yeah.
All right.
Dump C again.
How much do we have in? Yep, dump C one more time here. How much do we have in here?
3.125.
All right, so about 3%.
Okay.
That represents all the fresh water in the world.
What?
Yep, and this plus that, we'll use yours, represents the water that's not fresh.
Wow.
Now, when we talk about fresh water, we're talking about what's in the ice caps. your streams, your rivers, in the atmosphere.
Wow.
All the groundwater.
Yeah.
So all the usable groundwater. That's all there is. Now, I'm going to give you another cup.
Okay.
I want you to divide it equally in 3. Now this is not easy.
No, it's not.
I'd say we should have used a smaller cup to make it easier, but if we used a smaller cup, it'd been smaller amounts. So I don't think it'd been easier.
Okay.
Got it?
Got it.
All right, take your unlabeled cup and dump it in C.
Okay.
All right, then the unlabeled cup is set aside. All right, so C, or that represents what is unusable fresh water. So that's actually in the polarized caps and all those places.
Yeah.
And so this represents all the usable fresh water in the world.
Huh.
Always did this in my environmental units
Yeah.
to show students how a little bit of water is really all we have. And so this is where we talked about being conservation and being able to take care of our water, why it's important. And I mean, we can go into, obviously, now we're talking about how humans impact the world at this point, and why it's so important to protect that small, okay, we'll use yours, that small amount of water.
Forgot about the same amount.
But yeah, we did pretty good. I have more on the table than you do, but I'm not sure
You have
why.
all the sponges though, so.
I did. I don't know why I left them over here. I brought 2 just in case we both needed one. Good thing I brought them. but and that's one more thing. I usually use sponges and stuff rather than using a bunch of paper towel, because otherwise you're just going to waste paper towel.
Yeah.
And the sponge we can just rinse out and reuse. But it's a nice demo. It gets their attention.
Definitely.
And so that's what I like about that.
Yeah.
And all it takes is some cups. I know I say it takes 3 cups and I label A, B, and C, but I usually use that 4th one. I've told people before, I'll put 1/3 in one and 2/3 in the other, but that's a little hard to
I like
estimate.
when you said separate it into thirds.
So that makes it a lot easier by having that extra cup there. And that's, not a lot of water. All right, though this is the last of the videos for this unit.
Yeah.
This is the last thing in this unit. Hopefully this unit was helpful and you got something out of it.
Yeah.
If there's other things that you would like that we didn't provide you with this workshop, then let us know. Drop us an email and let us know, hey, do you happen to have demonstrations on this particular topic? We're getting ready to teach. Now, don't email me on a Monday because you're teaching it on a Tuesday and think that either of us are going to be able to. I only say it because it's happened. It's happened. I've had teachers email me at 6 a.m. saying, hey, I'm teaching this today. Do you have anything for me? And I thought, I got a little video. It's called Time Management. And you did not follow that video. But I didn't really say that. I actually got stuff together. But so let us know if you're like, oh, I struggle with this, that, or the other. We will try to find somebody to be able to help you guys.
Yeah.
This is really, as outreach coordinators, this is what we do.
We want to hear from you. We want to know, what are your needs? What are the sorts of things that you'd like to see?
It's our job to put things together that's going to be helpful to you. And so feedback to us, hey, we found this helpful, or hey, it would be helpful if I really need help with.
Yeah.
Let us know.
Yeah.
Let us know. I'm Earth Atmospheric Planetary Sciences, just in case you couldn't tell. She's
Department of Chemistry.
Purdue.
Just Purdue.
Department of
Chemistry doesn't have cool shirts like it. Well, we do. I just
you
wear
do.
it.
You just didn't. Yeah, you didn't have one yet. It's when you've been in a department for 15 years, you
Okay, that's
have
fair.
nothing but these shirts.
Right.
Half my wardrobe is these shirts now. But
Half my wardrobe's still high school shirts. So.
yeah, that's fair. And we have people in biology. I mean, we're part of the College of Science,
Yes.
biology, physics, computer science, mathematics. We know people in all of
Yes.
these, and so sometimes the faculty and stuff we're contacting is a little busy. Don't expect answers right away. Then other times they're like, oh yeah, they quickly answer something, and we can get that back to you. We had an incident of that today where
We did,
someone
yeah.
asked a question, and I'm like, oh, I don't know. And I sent it to 3 of my faculty, and two of them got back to us by the time I ate lunch. And so sometimes it works out well.
Yeah.
Other times it takes a little while. But let us know how we can help you. That's why we're here.
We're
Thank
happy
you.
to help. Yeah.